Hello, ladies. Today is Wednesday. It is a Zoom lesson, just giving you the heads up on what the rest of the week will look like. Tomorrow, you will get a quick quiz review on systems of equations by substitution and elimination. And then Friday, you'll have a short quiz on systems of equations by substitution and elimination. So today, we have this Zoom, and then you have a few questions to complete independently, just I think 2, 3, or 4, I forget. But yeah. That's the agenda for the rest of this week. So today's learning target is I can solve a systems of equations by using substitution and elimination. So this is basically just a recap of what we've been doing the past few days. So it isn't going to be a very long lesson. So we have our model problem with the steps next to it for substitution and an elimination. So our first example, we want to solve the following system by using substitution. We have y equals 4x plus 6 and negative 5x minus y equals 21. So step 1 says isolate one of your variables. If you look, one of my variables is already isolated. It's my y. My y is isolated because it's in the form y equals or x equals. Step 2, substitute that expression from step 1 into the other equation. The resulting equation should have only one variable, not both an x and a y. So everywhere I see a y, I'm going to substitute this 4x plus 6. So I'm going to rewrite that second equation, that negative 5x minus y equals 21. And everywhere I see a y, I'm going to substitute a 4x plus 6. And whenever you substitute something, always wrap it in parentheses. So now step 3 says solve that new equation. This will give you one of your coordinates. If we look, this will give us our x coordinate because everything's in terms of x. So I'm going to distribute that negative to each term on the inside of my parentheses. So I'm now left with a negative 5x. My positive 4x becomes a negative 4x. And my positive 6 becomes a negative 6. And that's all equal to 21. I'm going to combine my like terms. Negative 5x minus 4x, that's going to give me negative 9x. So I have negative 9x minus 6 equals 21. How do I get rid of my minus 6? I'm going to add 6 to both sides of my equation. So I get negative 9x equals 27, and then divide both sides of my equation by a negative 9. Getting x is equal to negative 3. We just solved that equation. Step 4 says substitute the result from step 3 into either of the original equations. I'm going to put it into my y equals 4x plus 6. So I write y equals 4x plus 6. Let me just make sure. Yep, 4x plus 6. And everywhere I see an x, I'm going to plug in a negative 3. So I have y equals 4 times negative 3 plus 6. 4 times negative 3 is a negative 12. Negative 12 plus 6 is a negative 6. And that's your final answer. Negative 3, negative 6. Perfect. Let me make it a little bigger. Okay, so that's how you solve a systems of equations by using substitution. Now let's go ahead and solve by elimination. So yesterday you might have noticed that I didn't really give a step sheet or a procedure. The reason being was because it's sort of just like, oh, look at your numbers, look at your relationship. But today let's look at how the procedure would actually look. So step 1, line up the x's and y's. I'm giving you the heads up, 99.9% of the time they will be lined up. Even the examples I give you, they'll be lined up. I'll be very generous. I'm not going to make you rearrange unless it's like a bonus. If we look, our x's and y's are lined up. I have my x's and I have my y's. The one thing I would add is put a minus 1 in front. That way you know that you're dealing with a minus 1y, not just a negative y. Okay, step 2. Look to see if one of the variable has opposite coefficients. If yes, then just move right ahead to step 3, so adding your equations to eliminate them. Or if it's a no, multiply one or both the equations by a constant in order to make the coefficients of the x or y terms opposite. So I'm going to ask you, what do you want to make what do you want to eliminate? So if I look, I actually think I want to eliminate my, doesn't matter. I'm dealing with two positives and two negatives. So, decisions. I'll eliminate my y's. So if I have a 1 here, I'm going to multiply this equation by 1. And if I have a 2 here, I'm going to multiply this equation by 2. Here's the issue. If I just keep everything like that, I'm not going to be able to eliminate everything. So I'm going to have to make one of them negative. I'll make my 1 negative. So I distribute my 2 to each term, distribute my negative 1 to each term. 2 times 7x is 14x. 2 times a negative 1y is a minus 2y. And 2 times 15 is 30. Distribute that negative 1. Negative 1 times 3 is negative 6x. Negative 1 times negative 2 is a positive 2. Oh, sorry, negative 1 times 3 is not negative 6x, it's negative 3x. And then negative 1 times 19 is negative 19. If I look, I can eliminate my y's just by looking at them. So 14x plus a negative 3x is 11x. 30 minus 19 is 11. Divide both sides of your equation by 11. And I get x is equal to 1. Now, I know x is 1. Solved for it. Now I gotta substitute that value I found to one of the original equations and solve for my other variable. I'm gonna choose my second equation. So I have 3x minus 2y equals 19. So everywhere I see an x, I'm gonna substitute a 1. 3 times 1 is 3. Got to get rid of that 3, so I'm going to subtract 3 from both sides of my equation. And then divide both sides by negative 2. And get y equals negative 8 as my final answer. My final answer for this question is 1, negative 8. And that's it for today. If you have any questions, email myself, Miss Townsend, or Miss Jimenez. Have a great day, ladies.